Hello everyone, my name is Livia Gibertoni and I'm happy to share with you my final project for the data science course. This project is titled Movie Genre Classification, and my goal was to explore how machine learning can be used to predict the genre of a movie based on different features such as duration, popularity, and social media data. So throughout this project, I used generative AI tools to guide the process from exploratory data analysis to model evaluation. All the code, data, and documentation are available in my GitHub repository for full transparency, and you can reproduce everything if you want. So let's begin. Why this dataset? I selected this dataset because of my personal interest in cinema. Movies are a powerful medium, and understanding how genre classification works behind the scenes can be both fun and informative. This dataset provided a perfect opportunity to combine my love for film with the technical skills I have been developing. The dataset includes a mix of numeric and categorical features, which made it an ideal candidate for in-depth analysis. It's also representative of real-world, somewhat messy data, which allowed me to apply data cleaning techniques and improve my practical skills. So let's talk about the dataset. The dataset was sourced from Kaggle and contains information on thousands of movies. Key attributes include the movie title, director name, duration in minutes, the number of Facebook likes for actors and directors, as well as some metadata related to the cast. And the target variable is the movie's genre, and it's what I'm aiming to predict using machine learning techniques. This dataset can be found on Kaggle. I will share the link in the presentation. And one challenge I faced was that some data was missing or duplicated, just like real world datasets. But that's what I made it an excellent opportunity to apply in essential data science workflows. Before jumping into models, I started with exploratory data analysis. This step helped me to understand the data, detect patterns, and identify potential issues. I used various techniques such as describe, info, and several types of plots, including histograms and block spots. And I found that variables like movie duration and director Facebook likes had significant variability in some cases, interesting correlations with the genre. I also used correlation heat maps to explore relationships among numeric features. This helped me guide my choice of variables for modeling. For example, I discovered that some features contributed very little and could be dropped. About outlier detection, outliers can distort the results of a regression model, so I paid special attention to them. Using box plots and visual inspection, I found several extreme values, especially in features like movie duration and Facebook likes. For instance, a few movies had thousands of likes or unusually long durations, which could be bias the model. I addressed this removing extreme outliers and applying transformations where necessary. This ensured the model would learn from representative data and avoid being misled by abnormalities. Modeling strategy. Once the data was clean, I created and tested three regression models: linear regression, polynomial regression, and ridge regression. I experimented with both single variable and multivariable models. Before training, I applied standard scaling and created polynomial features for more complex relationships. To evaluate performance, I used metrics like R squared and mean squared error. For the ridge model, I also used grid search CV to find the optimal value for the regularization parameter alpha. All these steps allowed me to compare performance and choose the best modeling approach for this dataset. The best result model results. Among all models, ridge regression with polynomial features gave the best results. Each achieved a higher R-squared value and a lower MSE, indicating it explained the data better and made more accurate predictions. One key insight was that multivariable models performed significantly better than single variable ones. This shows how combining multiple features can improve the model's predictive power. It's also interesting to observe how regularization in random regression helped reduce overfitting and lead to a more generalizable model. How AI helped? Generative AI was a big help throughout this project. I used ChatGPT as a coding assistant, especially during the cleaning and modeling phases. AI helped me to write Python code for handling missing values, creating plots, and building regression models. More than just coding, it helped me understand how to structure my analysis. For the use of AI accelerated the process and gave me more confidence in applying best practices, especially when fine-tuning models and validating results. This project allowed me to apply all the key stages of a data science workflow, from data cleaning and exploration to model evaluation. I learned how important it is to handle missing data and outliers early on, and how different modeling techniques can yield very different results depending on the processing steps. Also, integrating AI into my workflow proved me extremely beneficial. It not only saved time, but it also enhanced the quality of my work. All the files include the dataset, the Jupyter Notebook, and AI-generated iterations are available in my GitHub and here in the presentation forum, and for anyone who wants to explore it further. And thank you so much for your attention. I truly enjoyed working on this project and learning from it. If you have any questions, feedbacks, I'll be happy to hear from you. And I hope this presentation gave you a clear picture of what I learned and accomplished. Again, everything is available on my GitHub and here in the presentation forum. And thanks again.